All right, thank you for taking that poll. I'm going to share the results here real quick. Brian, can you see the results?
I can. It looks like over
Okay,
half
good.
our audience is DBAs.
Yep. So the poll was for the recording. The poll was the question was, what is your primary job function? And the three responses are, I'm a developer, I'm a DBA, I'm an involuntary DBA / sysadmin. I kind of sort of have to do this or it won't get done kind of a situation. And 55% say they're DBAs, 27% say they are developers, and then 18% say they are the involuntary DBA. So thank you everyone for, excuse me, for sharing that. I appreciate it. And with that, we'll start the session here. I'm trying to. All right, so yeah, so welcome today to our database administration virtual group. Today's session is no SQL Server, sorry, excuse me. Throat's a little dry this morning. SQL Server Security Basics. What you need to know to work with SQL Server security properly. And today our esteemed speaker is Brian Kelly. It's great to have Brian here today. And I'm the moderator today. My name is Mike Clark. Good morning, everybody. Anyway, so I want to say thank you to our sponsors. We have a couple sponsors here for the virtual group. Today's one of the sponsors for today is AWS. We thank you for the support of AWS. Electronic and this current technology makes things very easy to do these kind of sessions. And then, of course, we're all sequestered at home pretty much around the world. And so online stuff is really where everything is at these days. So with their support, we're able to pull this off a lot more smoothly and professionally. We appreciate that. Another one of our sponsors is HVR. So we appreciate these guys a lot for coming alongside the virtual group and supporting us in such ways. This group is part of PASS, and if you don't know about PASS, you can go to pass.org. It's a free membership. You can get access to a lot of online content, and during this this quarantine time frame, PASS is actually doing much more online content than they normally do. They normally do a ton, I think, but they're doing even more now. So if you're not familiar with PASS, go to pass.org and spend a few moments looking around to see what they have to offer. I'm sure you'll find something that'll suit your needs and interests. One of the things that PASS does, they do a lot of online things. They have something coming up tomorrow. It is the secure data storage. So that's a PASS marathon. So if you go to pass.com and click on the marathon, there's a banner of it right there. It's going to focus on a framework and strategy for your data platform. So if you're interested in that and have time tomorrow, please go to pass.org and click and register for the marathon. Another thing that PASS has, they have a PASS Summit, and so these are all community led. So that means there's a call for speakers right now. We have another week and a half, 2 weeks to submit topics and thoughts for the upcoming PASS Summit, and that's going to be in the middle of November. And so there's time to register for that and plan for that. So if you have an idea and want to speak at PASS, we still have time to take speakers. SQL Saturdays are coming up. The SQL Saturdays that have been planned for all of April and most of May have currently been suspended. They'll possibly be rescheduled later in the year, but right now, in May and June, we do have some that are coming up. Some in Italy of all places. We hope they're recovered in time for that. But if you want more information, go to stay tuned at SQLSaturday.com. That's right now everything's kind of in limbo, but if you go to SQLSaturday.com and keep track of which ones are available, you can register for those. So today's topic is, as we mentioned, today's speaker is Brian Kelly. As you know, Brian is as you saw on the list, he's an author, a columnist. He's a certified information system auditor. Brian does a lot of things. So today he's going to bring us a pretty good introduction to SQL Server Security and what we need to know to pull this off. And with that, Brian, I'm going to make you presenter and we'll take it from there.
All right, hello everyone, and thank you for taking time out of your day. I know for a lot of folks working from home, they're also dealing with their kids. And so thank you for spending your time, your hour with us today. When I was thinking about topics for SQL Server security in general, one of the people in my user group, I'm a local user group leader in Columbia, South Carolina, mentioned that a good, just foundational presentation on SQL Server Security Basics would be good. And then Mike approached me and said, "Hey, do you got a topic to talk about?" And I said, "Well, I just put this together." And so that's why we have what we have today. So a little bit about me, beyond the obligatory bios that we always submit as speakers. And I am the kid who never figured out what he wanted to be when he grew up. So I bounce around a lot. I do infrastructure security architecture work most days. And I've been a database administrator, data architect. Officially, my title right now is data infrastructure and security architect, again, because I can't figure out what I want to do. And I am a certified information systems auditor, and I do write a lot. Tend to write at MS SQL Tips. Do have columns at Redgate's Simple Talk, and some older columns at SQLServerCentral.com. And if you're not familiar with the Center for Internet Security, we do have security benchmarks on most major software packages and operating systems. And myself and Sean McCown and a couple of other folks are the editors for the SQL Server related ones. And those give you what we consider industry best practices, crowdsourced, community sourced, to figure out the best ways to secure your SQL servers and the rationale and the reasoning behind what our recommendations are, because a best practice may not be a best practice for you. That's why I think some people in the industry have started calling them good practices, and you figure out which ones are applicable to you. So enough about me. Let's talk about what we're going to look at today. We're going to start with some basic security principles, the underpinnings of what we model security on. These are true regardless of the IT domain. These are information security principles in general. So we'll cover those very briefly. Then we'll go into authentication and authorization, what the differences between the two, and how SQL Server handles them. We'll talk about the SQL Server permissions architecture, because in a lot of cases, what I have found is some folks have a good understanding of SQL Server permissions architecture and some people don't. And some people think they do and they don't, and vice versa. And so this is kind of just a coverage, filling any gaps that you might have. And then we'll talk about a topic that I've actually found a lot of people, because of ORMs and other things, have kind of not heard about or learned about, or if they used to use ownership chaining, they've kind of forgotten about it, and why it can help extremely well in a security context, especially when you need to control access to the data. And you have especially cases where you might have end users who have credentials that can access SQL Server outside of, say, an application, because of how that works. And we'll get to that topic at the appropriate time. So let's start with the basic security principles. And these are the foundational concepts, like I said, for anything with regards to IT security. Whether we're talking Active Directory, we're talking network security, we're talking SQL Server, Oracle, it doesn't matter. This is the general set of foundations that you take things back to. So the first one is something we call the C-I-A Triad. And if you study for almost any InfoSec type test, Security Plus, CISSP, you're going to see this. Sometimes it's not called the Triad. Sometimes it is relettered depending on the focus area, but effectively you have these three ideas. Confidentiality is the idea that only authorized people using authorized processes have the ability to read data. Integrity is the right operation, right? So in SQL terminology, SQL terminology, we're talking insert, update, delete. Only authorized people using authorized processes. And I include that phrase, authorized processes, for a reason, because if you've been a DBA a long time, at some point in your career, you've had the user who connected to SQL Server with their credentials because their application was a fat client that ran on their desktop, and so it connected as them, and they figured that out, that they could use Excel or Access to connect to said database, and they probably tied, say, Access to a table, and thereby caused a table lock that completely froze the core application itself, right? Access in this case is not an authorized process. The user may have the permissions to, but from a business perspective, they're supposed to go through the app. So authorized process is a key point. And availability is one of those topics that security professionals tend to forget, maybe on purpose, because they like to lock things down. And I've certainly been guilty of it as a security professional. It's the idea that the system is available to perform the functions that are needed by the users. Anything less is actually a security issue. Now, think about what I just said there, right? If I lock down a system too tightly where my end users of that system can't do the job that they're required to do, that's actually a security issue. Availability is. Some security professionals, oh, that's not my problem. You just need to figure out a better way. But the reality is that there may not be a better way, and there may not be, or there may not be time to do the heavy research. Availability is just as important as confidentiality and integrity, because a system that's unavailable is useless to the end user, or a system where only some of the functionality that's needed for the job is available and the rest is not, it doesn't do the end user and the business any good. And that's something to always keep in mind with regards to security. That's why sometimes we'll make the decision to choose a simpler option rather than get very, very granular. And I'll give you a great case. It's not SQL Server related to show this as a overarching principle. If you spend any time talking with Microsoft's Azure cloud architects, especially on the security side, they'll tell you to use the Azure roles, even though you may want more granular permissions, because you never know where that role is being used or grants access outside of what you think it does. And that's really important, because in SQL Server with 2005, 2008, 2008 R2, there were some system stored procedures where Microsoft's guidance to us was, hey, give everyone a particular permission, don't make them a member of the sysadmin role. And then we went to run certain stored procedures and we couldn't do it. And then what we did is that some of us dug in and looked at those stored procedures, the system stored procedures, and we found that they actually referred to the role by name. Right, they actually referred to sysadmin, and there was a check. If the user was a member of sysadmin, then they were allowed to execute the stored procedure. If they weren't, then they got an error message, right? Even though they had the permissions to execute it, the SQL Server stored procedure itself checked inside the code and kicked them out. And so availability sometimes means you make a trade-off between what you would really like to do and what you need to do just to get business folks working. So with that, the principle of least privilege kind of flows out of those three words: confidentiality, integrity, and availability. And it's basically, you can go online and you can find very wordy 5-6 sentence definitions for principle of least privilege. When I explain it, especially to business folks, I basically say it like this, exactly what's on the screen. It's only what's needed, no less, no more. Because if you give too little, like I explained with availability, the job doesn't get done. If you've gotten and given too much, you've increased the risk. And the case in point is that it may not be that the user that you're granting the permissions to is untrustworthy. However, anybody can fall prey to a phishing attack, click the wrong link in an email, and suddenly have malware that doesn't get detected by your antivirus or your endpoint protection systems. And they're using a method that at this point doesn't get seen by the various intrusion prevention, intrusion detection systems out there. And there's a backdoor into the system running into the user's credentials, and it's an adversary who is definitely untrustworthy, an attacker who has gotten into your system under that user context and started executing queries and doing other things. So only enough to do the job, nothing more, nothing less. The last one really is the defense in depth, and that's not to put all your eggs in one basket, to use another cliche. And that's the idea that I'm going to have multiple layers of protection, different technologies, different mechanisms, different structures, right? Because if I put, say, 2 Cisco firewalls, one right after the other, in order to protect a web server, for instance, if there is a vulnerability that affects the Cisco firewall, well, if it affects the first one, it affects the second one. It's not really a defense in depth strategy, because I can go through with the same type of attack, right? Now, if I've got a Cisco firewall and then I've got some other type of firewall that's completely different from Cisco, the likelihood that the same attack will work is not very high. And so when we start talking about protecting our systems, we want to think about multiple ways to protect, but not getting so complex that we lose ourselves in the security. Because if you make a security architecture too complex, what ends up happening is people forget, and even if they have the documentation, where the security is actually being applied, or what thing is doing what. And if you're especially trying to troubleshoot why someone has access or why someone doesn't, it may just get lost. But you still want to try to have multiple layers if you can. And if you've ever played the old game Breakout, then you know exactly what I'm talking about. You try to get through each layer. You can't get through, you can't clear all the blocks until obviously you really punch through, in this case, all 6 layers, and you get that ball on the other side where it can just bounce around from the top of the screen to the other rows. It's a really simple concept. Break through, get the ball on the other side, and let it bounce around and do the work for you, so you don't have to take a chance on missing the ball when it comes back at you. It's the same idea in security. The more layers that I can smartly put between me and an adversary, the harder the job is on the adversary's part to get through, and the more likelihood that I keep my stuff protected, and that I have a chance at catching the adversary as they try to come through my systems. So let's move into SQL Server specifically, and let's talk about how SQL Server does authentication and authorization. Now, in this first part, I'm going to focus primarily on authentication. We'll look at authorization in detail when we start talking about database permissions. The reason I put these two together is in security literature, you'll often see things like the 3 A's or the 4 A's. The third A is usually auditing. In any case, we're focused right now on the first two, which is authentication and authorization. And really the difference between the two is authentication is you proving who you are, or Mary proving who she is, right? Or said system proving it is that system and not some rogue application. That's what authentication is. It's proving identity. Authorization is once identity has been proven. Once you have shown me your driver's license and I validate it and I know it's you, what are you allowed to do? That's what authorization is. So that gets directly into permissions. One of the reasons I include authorization together up front is we're going to talk about how SQL Server does its security model between servers and databases. And that actually comprises some authorization, even before we get into permissions within the database itself. So authentication, like I said, is who you are, right? And if you think about it, you log into Facebook, you log into your Windows computer, you log in wherever, you're using a username and password, and hopefully you've got some other multi-factor system, whether it's a one-time password system that has a synced algorithm, it's verifying for fingerprint or something like that, but you're basically saying, yes, this is me, it's not someone else, it's not someone pretending to be me, right? With regards to SQL Server, when SQL Server does authentication, what it's verifying is what we call logins, okay? If I have a login to SQL Server, it's verifying that I actually have a credentials that matches one of the logins it knows about, and we'll get to that in a demo example. Now, part of the confusion is, as of SQL Server 2005, Microsoft introduced another phrase, which is server principals. So if you go query the database, you'll see a catalog view called sys.server_principals, and that contains all the logins, both Windows and SQL Server based, and also I think, but there's another one called sys.SQL_logins, and there's some confusion there. Realize that logins and server principals, as far as SQL Server is concerned, is interchangeable as far as what the meaning is. Now, if you go and write TSQL code, as we will in the example, you do have to use specific words like create login. You can't do create server principal. So while from a jargon perspective, they mean the same thing, they obviously do not when in regards to implementation of the TSQL language. Now, when we talk about authentication, there are 3 types that we're concerned about with respect to users and systems, right? We're not talking about anything more complex, such as a mirroring relationship between 2 SQL servers or an availability group or anything like that. We're talking about what a user or a service, like a web service, uses. And those are Windows accounts. And what I mean by that are Windows user accounts, right? They could be what we call managed service accounts or group managed service accounts. For effective purposes, as far as we're concerned, they're the equivalent of a Windows user. They could be computer accounts, right? Because I can assign a computer account to have access. And you often see this when you have, say, a web application and it's running under one of the less privileged identities with regards to its app pool. It'll appear to SQL Server as the machine name, which is usually domain / the name of the computer with a $ at the end, right? That's a Windows account. And so that's what I mean by Windows accounts. Windows groups, those are security groups, right? Usually containing a list of accounts. They may even have nested security groups, so on and so forth. We prefer to use Windows groups where we can, because it makes our job easier. It means that handling changes to security with regards to people changing roles or being added to the organization or being removed from the organization, we don't have to worry about we're using a security group that's been given to us by whoever is in charge of our identity access management. And as they manage those security groups, permissions change with respect to the users on our SQL Server. It's not always, we don't always get what we want, but that's what we try to shoot for, is to use Windows groups. And of course, there are the cases where you still have to use SQL Server logins. If you don't have that domain trust type relationship, such as you've got a computer connecting from an untrusted domain, or a computer's not on a domain at all, for instance, a web server sitting in the DMZ facing the internet, so it's not, doesn't have access to the domain controllers, and so it can't be on the domain, you may have to use a SQL Server login. A lot of third-party products still use SQL Server logins. Products that monitor the availability of domain controllers, for instance, will definitely use a SQL Server login, because they want to be able to write the fact that the domain controllers are unavailable. And if you're using a Windows login that relies on the domain controllers to be available, you're going to see a failure. So you'll see cases like that as well. In any case where you have a situation that you can't use a domain login, the SQL Server login is available to you. I see a lot of times when people use SQL Server logins, they don't have to. That's what we try to minimize as much as possible. We try to push back to the Windows logins. So let's look at some of the things that we can do with regards to authentication and with regards to logins in general. So let me switch over to Management Studio. All right, so I've brought up Management Studio, and I want to make sure I've got Zoom it up. I do. Okay, so yep, Zoom it's running. All right, so the first thing I'm going to do is a SQL Server based login. Now, with a SQL Server based login, one of the things that you notice is I've specified the password here. So in this particular case, SQL Server functions as the security system for authenticating the user. And what I mean by that is SQL Server is going to know how the user logs in with the login name, SQL Server based login in this case, and it's actually going to store a hash of this password, which it will generate from what is being specified here. Now, if you're running extended events, or you're running SQL Profiler and SQL Traces, if you're not still on 2008 R2 in Azure, please move to extended events. It will hide the fact of what was here. It'll say that a create login event was run or something along those lines. But I have to set a password. Now, I've made it a very complex password based on what complexity rules are. There's upper lowercase, there's numbers, there's a special character, it's over a certain length. So this one should run just fine. I could disable some of the security checks, but generally if you don't have to, don't, except for maybe password expiration. If you have a case where you have an application connecting to a SQL server, we generally tend to leave those as password never expires. And then from a outside perspective, we usually have some sort of control, maybe a query that monitors for how long the login has been since the password's been changed. We do that on the Windows AD side as well. So if we execute this, we'll see that it completes. And if I refresh my logins, there it is right there under renamed SA and over Wild World Imports DB owner, SQL Server based login. So pretty simple to create. The other thing we can do is we can create from Windows. In this particular case, I'm going to create a login that is based on a Windows group. On any system, the built-in users group is available. This system is a demo computer, so I don't have a domain access. So I'll execute this. It'll create it just fine. And right underneath built-in administrators, you will also see built-in users now show up. Now, all I've done is given the logins the ability to connect to the server. I actually haven't given them the ability to connect into the databases itself. That's actually an authorization process. And we can do that by actually creating what we call users. So I'm going to create a simple database, blank database, should take a couple of seconds to run. I'm going to switch to it. And then I'm going to create some user accounts. So first, I'm going to create a user from that SQL Server based login that I specified. And notice that the syntax is fairly simple, right? And then I'm going to create one from the Windows group. And then I actually can create a user within the database that isn't a login at all. This is great for demos or great for particular security use cases, but generally we don't do this on a production system unless there is, like I said, a definite use case that we don't want to log in tied to something, right? There we go. Now, if I refresh my databases, we should now see SQL Server Basics demo. If I expand it, I should go to security, and under users, I now see Jane Smith, the SQL Server based login, the built-in users. Those are the 3 that I created. Now, if you aren't Jane Smith or a SQL Server based login, and you are not a member of built-in users for this particular computer, you do not have the ability to get into the SQL Server Basics demo. I don't care who you are. Now, because I gave built-in users access, pretty much everyone does. But if this was a particular security group, say HR users, right? Even if I hosted that database on the same SQL Server as another database, let's say you hosted it for your SharePoint site for your company intranet, right? If someone had access to the SQL Server and was given access to the company intranet, that doesn't mean that they have access necessarily to your HR database, which HR users have access to. Now, there are some server level roles such as sysadmin that give access downward into all the databases. But if I'm a normal everyday user, or I come in through a normal group that isn't assigned a very elevated role within the SQL Server at the server level itself, I don't automatically have access to a database. It has to be granted, and this here is how we do that. Now, technically, that's an authorization because SQL Server has already validated who you are, right? Now it's saying, what do you have access to do? Oh, you want to access that database. Let me see if you actually have permission to do so. That's what that create user does. And if you run the queries against sys.database principles and database permissions, which is a presentation for a different time because it's a pretty involved topic all of itself, you'll see that certain particular permissions get added. A connect permission gets added, and actually the connect permission gets added at the server level as well. So that's a little bit about authentication and just briefly about authorization. But when we talk about authorization, realize that we have multiple levels. I mentioned that there are some things at the server level that they give you permissions at the database level. And that's because SQL Server is based on a hierarchy, which we'll get to in a minute. But it goes below the database level. We also see it directly against objects. For instance, we often see where we give permissions directly against stored procedures, directly against tables. There is a better way, and if you can design it that way, we'll cover that in a second. And one thing that I do have to mention, because some people who are just starting out with SQL Server, they don't have this clearly in their head, is if you don't have a permission defined by any of the security mechanisms that SQL Server recognizes. For instance, if it looks through all the logins and all the security groups, and you don't have a permission to do something on a database through any of those means, then you don't have access. SQL Server starts with a default you are blocked from doing it unless it has explicit permission saying that you do. Now, with that said, there are a couple of roles within the databases that do give implicit rights, but you have still been explicitly granted membership into those roles. And that's something to keep in mind, is that you may check the permissions table and say, well, I don't see they have access to that table. They might be in a role that gives them access. But in any case, if you don't have anything like that, SQL Server is going to say, sorry, you don't get there from here. You're not authorized. And that's something to keep in mind when you're building a security architecture for SQL Server. You only have to define what people are allowed to access, because SQL Server will block them by default. So when you connect to databases, like the example that I showed you, it is technically an authorization. And notice that we use a different keyword with regards to TSQL. We use create user, and if we're taking it from a login, we do indicate what login we're taking it from. So there is differentiation there. One of the reasons that in SQL Server 2005, Microsoft started calling things security principles, like logins being called server principles and users being called database principles. If you think about the word user, it has different meanings depending on context. And so in order to try to move it to where everyone spoke the same language, they started using the phrase database principles. The problem is we still use user, and because we still use user, that's why you have a create user statement, right? And so that's something to keep in mind when you hear user and database principle. Database principle does mean user as in a user object or a user or a role within a database, but a user may be referring to a person. And so listen closely to the context or read closely the context to make sure you understand. Logins and server principals aren't too hard, but user, because of its multiple meanings, is why Microsoft tried to make that change. It just didn't stick. And so now we have both terms. Now, like I said, you can have login access to a server, but not a database. You have to be given either a particularly highly privileged role at the server level, or some sort of server level permission that carries down, which we'll get to in a second, or you have to be given explicit access by means of a user to connect to a database. So you could host multiple applications on the same SQL server and keep security distinct such that users can't go across unless they should be in a role that allows them across. So that's just something to keep in mind with regards to server level versus database level. And I know that sounds confusing, so let's look at a quick diagram. So here in the United States, we have a lot of self-storage facilities. And basically the way this works is that it's a big, huge lot, some sort of real estate, usually fenced, and usually to get into the fence, there is a key code system or a swipe system with a card, right? You get in, that lets you onto the land where all the storage units are. And you go in and you rent an individual storage unit or two, and usually you have to provide your own locks, okay? So you come in, you get a storage unit that you're paying to store your stuff because you have too much stuff for your house, and you put your locks on, and whoever has the storage unit on either side of you, they have their own locks. So you can get into the whole facility because you know either the punch code or you have a card swipe. So you can drive on, and you can drive right up or walk right into your particular storage unit, and you can see the two storage units beside you. But unless you have the keys or the combinations to the locks that they used, you don't have access to their individual storage units. You only have access to yours, right? SQL Server has that same model. If you think about getting onto the lot, going to that passcode system or that swipe as the login level, and then each storage unit as a database, you get an idea of how that works, right? I can have an access into the lot, say the SQL Server, while not having access to some of the individual storage units or databases in SQL Server terminology, only the ones that belong to me. And that's how you kind of understand the difference between logins and users. And if you are dealing with a brand new IT auditor, IS auditor, you may have to spend some time and by all means use the slides, use this diagram to try to explain it to them so they get the distinction between a server level connection permission and connections into individual databases. Because I certainly had a case where an auditor says, well, they have permission to SQL Server, so they can see they can access every database that's on that SQL Server. The answer to that is a definitive no, unless they have a higher privileged role or unless you've done something to give that user access to every single database. So let's talk about database access briefly. And actually, let's go on to permissions because I covered the access with the first one. So permissions, to understand permissions within SQL Server, realize that anything that you can assign a permission to has a particular name. It's called a securable. That's the jargon. You just have to learn. It's in the literature, and anything that has the ability to be assigned permission is a securable. So that's a table, that's a stored procedure, that's a schema, that's a database, that's the server itself, right? As far as SQL Server is concerned. Now, there are specialized securables called scopes, and all scopes are securables that themselves can contain other securables, right? So if you want to use an analogy, think about files, those are securables, and you have folders. Well, folders you can assign permissions to as well, right? So they're both securables from that perspective at the file system level. However, a file can't really contain another file. Now you can embed a file in Word or something like that, but technically speaking, when I say a file, it doesn't contain another file. I can't open up a file and then double click like I can with a folder. A folder, however, can contain other folders and other files. It is a container in and of itself. In SQL Server terminology, that's a scope. Now, where that analogy breaks down is that you won't see scopes of the same level nested within themselves. So in Windows, I can nest a folder within itself. I cannot nest a database within a database or a schema within a schema as far as SQL Server is concerned. That's one of the main differences. Now, there are 3 levels of scopes. There is the server level, that makes sense. The server level scope contains database scopes, and database securables, if you want to call them, whichever term you want to use, but it also contains other securables like logins, like server level roles, depending on your version of SQL Server, and other things like connections and endpoints and that sort of stuff. Databases obviously contain their own securables. Your tables, your stored procedures, your views, your functions, everything else, those are actually stored in containers called schema. So if you see something like DBO dot whatever, DBO is actually the schema. Database contains those schemas, and it also contains other objects that don't necessarily fit within a particular schema. For instance, a user is a securable that is that is underneath the database, so it's within the database scope, but it is, of itself is not within a schema. Permissions follow the hierarchy. And what I mean by that is if you have a permission at a higher level in the hierarchy, so you have a permission at the server level, it will go downward as long as it's appropriate. If you have a permission at a schema level, it will give permissions anything contained with that schema so long as it makes sense. Now, I know that's a little hard to understand with just words. So back in the 2005 days, I did this very quick graphic, which kind of shows the 3 scopes: server, database, and schema. It shows how there are securables outside of the lower level scope. So for server, for instance, I list endpoint and login. But then you see database, and you see a bunch of things in database that aren't within the schema scope. For instance, your asymmetric key, your symmetric key, your certificates if you're doing encryption. But then you see within your schema, you have your tables, your views, your functions, your stored procedures. So what does this mean as far as hierarchical in nature? If I grant an execute permission against the schema, well, execute applies to stored procedures, right? What that means is I don't have to grant explicit executes on every single stored procedure that is within that schema because I've granted it at the schema level. SQL Server will go, oh, they have execute at the schema level, therefore it applies to stored procedures within the schema as well. So if Jane Doe has execute against the HR schema, then that means that she has execute rights against any stored procedure written in and put into the HR schema. Likewise, if she has select rights against the HR schema, she has select rights against every table and view contained within the HR schema itself. And so that's what I mean by hierarchical. And obviously, if you put it at the database level, it navigates down to all the schemas and then down into all the objects thereof. And like I said, it's only appropriate. Execute doesn't matter or doesn't mean anything with regards to a table. So granting execute on a schema doesn't give access to a table because that permission doesn't apply. And it's easier if you can apply permissions at a schema level, and I'll tell you why. So once upon a time, when we did a lot of database deployments and we didn't do, say, execute rights at a schema level, and we did a lot of stored procedures, you had to make sure that if you were dropping and re-adding a stored procedure, which was often the case in a lot of deployments, you also included the permissions to be re-granted, because once you drop a stored procedure, SQL Server drops the permissions. You go to recreate the stored procedure, well, the permission no longer exists, and lo and behold, as Murphy's Law would tell you, you go to run the test, and of course, what would break is the key component of the application, because that's the stored procedure or set of stored procedures you forgot to properly put permissions against again. And so we spent a lot of time as DBAs checking the code for drop and create statements and making sure at the bottom of them you had your grants, right? Well, if you're at the schema level, if I've already granted execute schema level, I can drop and recreate stored procedures, for instance, all I want to, and they'll just work. And that's one of the reasons why you want to consider putting permissions against the schema if you can organize your code and your database objects accordingly. So it can be applied directly against an object. If it's applied against the scope, like I said, it's inherited. Only permissions which are applicable. There is a case where you do have a schema object owner exception, and we'll get into this with regards to ownership chaining very briefly. And it basically helps you understand how an ownership chain can form and why it can form. So let's look at permissions really quickly. So let's go back to the Security Basics demo, and I'm going to create a schema called test. And then I'm going to create a table and I'm going to create a role, and I'm going to grant select against that role. And then I'm going to grant Jane Smith, the user that we created without a login beforehand, and I'm going to create another one, John Doe. Okay, now Jane is going to be a member of this role I created that has select against the table. John is not a member of any role other than public, which everyone gets by being a user in the database. So let's go ahead and execute all that. And then I'm going to come and I'm going to execute a select as Jane. Now remember, Jane is a member of a role that gives her permission to select on the table. So this will function just fine, right? We should expect to see a select with no errors. No rows because we didn't put any rows, but it works just fine. Let's look at John. Remember, John has no additional roles other than public. Public wasn't given any roles, nor as a general rule should you ever give public any permissions other than what it has out of the box. So John should fail here, and we should get a nice big error, and we do, right? Very simple. User into a role has permission, user is able to select against that particular object. John, who isn't a member of a role, can't. This is a pretty simple example. Let's look at something which really puts things into perspective. So we'll use the same database, and I'll make sure that the slides and the sample code are available for you. I'll get with Mark and Mike, we'll figure out where to post it. I'm going to create two new schemas, ones that actually make sense from a perspective of state parks and rentals for cabins, right? So I'm going to have one that has to do with business. All of my business objects and business logic will be there. And I'm going to create one called accommodations that has to do with the cabins themselves, right? So I'll create two schemas. And then I'm going to create a role. I'm going to call it a reservation agent. This person is going to be able to execute any code, any stored procedures that I put within the business schema, right? So we'll go ahead and do that. And we'll make Jane a member of it. Now, I'm going to create some objects. I'm going to create under accommodations, the park. I'm going to put in a couple of parks that are right here in South Carolina that I know have cabins. And then just to verify that we have all that set up, we'll do a quick select. We do. Then we're going to create a set of accommodations for the cabin, which tie the cabin to the park. So we're using a lot of integer values, and then we'll make sure all that maps up. Basically, this is just a mapping table. And there we go. So cabin number 1 for park ID 1, cabin number 2 for park ID number 1, and then cabin IDs 3 and 4 for park ID 2, and you see cabin number 1 and 2 for the various parks. So let's create a table that has availabilities, and this is for December, and I'm going to go ahead and set a couple of dates available for the cabins. And then just to show that we have the availabilities listed and the availability flag is yes, we're good. So at this point, these particular cabin IDs on these dates, all 4 cabins that we know about in our park system, have availability for those 2 dates. So let's create another table within the business called reservation. And we're going to create a procedure that looks to see if a reservation date is available. And then if it is, making it unavailable so that we can book it. Okay, now you'll notice that I'm switching schemas. I'm actually going from business to accommodations, right? This is going to work because of a principle called ownership chaining, which we'll look at in just a minute. Remember that the reservation agent has the ability to execute any stored procedure within the business schema. And if you go back up in the code, notice where the stored procedure is. It is in the business schema. So what that means is that Jane Smith is going to be able to execute this just fine. All right, so I need to create the table for reservation. Let's go ahead and do that. And then we'll create the stored procedure that actually allows us to book a reservation or schedule a reservation. Now, like I said, we're using a stored procedure from business that is touching a stored procedure or touching a table in accommodation schema, and it's going to work because of a principle called ownership chaining. And we have a demo for that shortly, right? Now, here is where we have the various codes, right? So if you notice, I'm going to do an execute here. But in order to really understand why the store procedure works and doesn't fail, if you have the right user, we really need to understand ownership chaining. So let's go back and talk about ownership chaining for a minute. So it's a security mechanism that I've only found to be within SQL Server. When you can use it, it's considered a recommended best practice, because what it does is it allows you to prevent direct access to a table. So in this particular case, I'm writing a store procedure to define whether or not someone can change the accommodations flag or the availability flag for a cabin, right? I don't have to give the reservation agent the ability to directly touch the table. That will fail. If they don't come through my store procedure, they don't get access. That's the basic idea before it. And it does actually reduce the number of permissions checks, because what SQL Server does is it looks at the owner of the objects, hence the name ownership chaining. So if you have one object that references another and they have the same owner, then what happens is the SQL Server is only going to check and apply the permissions on the first object. So in the case of Jane Smith, if she has the ability to execute the store procedure, and the store procedure and the table both have the same owner, then what SQL Server is going to do is it's going to check the permission against the store procedure. Jane has it, and it's going to execute the store procedure. Inside the store procedure, when it gets to that referred to object, it's going to go, oh, well, owner's the same, so the owner must have intended that through this stored procedure, access is granted as long as they're within the context of the stored procedure. So in other words, I can do whatever I need to against that referred to object as long as I'm within the context of the stored procedure. If I'm outside the stored procedure and try to run it like a query on my own, it'll fail, right? So if I have the ability to update through the stored procedure, then as long as I execute the stored procedure, the update works. Go outside the store procedure, try to run an update manually, or even something as simple as select, I will fail. That's what ownership chaining gives us. So if you think about the context of what that means for us, it means I can ensure that you can only delete one row at a time, for instance, to an application. It means that if I've got to grant you the ability, your user account, the ability to access the database and the database objects with regards to security. If I'm writing the application, I can put all that access through stored procedures. Now, if you're smart enough to figure out how the stored procedures work, then yes, you could execute outside the context of the application. But what you can't do is my million row table that the application is using, you can't go and explicitly execute a delete from table. Doesn't matter whether you specify a where clause, it won't work. That's what we're after with ownership chaining. We're controlling access to the referred to objects. And usually what we mean by that are tables. So here's a good example, right? I have a store procedure, test.usp_aproc, referring to a table, test.atable. Not the best of naming conventions, because we try not to do that prefix naming convention anymore, but I wanted it to stand out so that you could see it was a store procedure versus a table. Now, test would be the schema, and as long as the owner is the same, then it should work. Now, in the second case, notice that I have test and test2. Those are different schemas. They can still work as long as they have the same owner. Now, accommodations and business were set up by me, by my user account. So that means that they have the same owner. So the thing about ownership chaining, and what we'll see with regards to the demo is that I actually never specified an owner for the objects. I ran them, so technically if SQL Server is going to apply ownership to the objects, such as the tables or procedures, it apply it to me. But if you ever query and to see who owns an object by looking at, say, sys.objects, a lot of times that principal ID will be null. And the reason for that is by default, SQL Server assumes whoever owns the schema also owns the object. Now, you can explicitly set the owner to be something different than what the schema has, generally frowned upon, and you might need to do it in a particular use case where you need to break a case of ownership chaining. But generally speaking, as long as the schemas have the same owners, then your ownership chain can form. I can have a store procedure in one schema, refer to a store procedure or refer to a table in another schema, such as a business store procedure referring to an accommodations table, and that ownership chain form. Usually, if I have objects within the same schema, we don't even have to think about it. Obviously, there's always that exception where someone is explicitly assigned an owner, but unless that's the case, it's going to have the same owner as long as they're within the same schema, right? And so we can now see that in the demo, because remember, I created a business store procedure that executes against an accommodations table. So let's create another user, this one called no permissions, just to see what would happen if we try to execute anything, right? So first, let's try and do the select. We should expect this to fail, and it does, right? Let's go ahead and try to book a reservation using the schedule reservation store procedure. We expect this to fail as well. And sure enough, the execute permission was denied. SQL Server hits that first object. You never get into the context of the store procedure because you're blocked at the start. I'm going to switch over now to Jane Smith. And remember, the stored procedure makes an update to this table, accommodations.cabin availability. Just to prove that Jane Smith doesn't have any permissions directly against the base table, I'm going to go ahead and run this. And we expect this to fail because we never gave her rights. And sure enough, the select permission was denied. I could change that to an update. We would get the same thing, right? But since you've been here for the creation of these and you'll be able to look at the sample code afterwards, you'll notice that I never give her any highly privileged roles within the database, and I never grant her direct access to the tables. I don't put her in a role that has access. I don't even create a role that has access. So if she tries to execute something directly against the table itself, like a select or an update and it's or delete, it will fail. Now, let's go ahead and execute the store procedure, which she does have the ability to execute because she was granted through a role the ability to execute anything in the business schema. And this should work. And we get a 0 back because notice I was returning the result code, generally a best practice with regards to SQL Server development. Run the store procedure, get a result code back. 0 means no problems, no errors. I get the 0 back because that's what I'm selecting. Now let's look if we have any differences between cabin availability and reservations. We should actually see flags switched in this first one, and we should see rows in our reservation table, a row. And sure enough, notice that this is now flipped to no, and we have our reservation. So that all worked because an ownership chain. The accommodations in the business schema are owned by the same user within the database. She has permission to execute store procedures in the business schema. The business schema store procedure refers to an object, a table, and the accommodations schema. But because the schemas have the same owner, an ownership chain forms, and through the store procedure, she's able to touch the table. Were she to do that outside of it, as we saw, she's blocked. That's the nice thing about ownership chaining. Very applicable to SQL Server development. So that's what I consider foundational stuff. Obviously, we can spend a lot more time in any of these. But at this point, I think this is a good stopping point to answer any questions because I've covered the 4 subjects. Let's see if there was anything that you all need more explanation on or something I didn't make clear.
Hi, Brian. Yeah, thanks. That was a great overview, and we will follow up and try and get other sessions going on here and coming down the pike in future. There are a few questions. There were a bunch of great questions, meaning they came in, and before I had a chance to answer them, you had a slide for that. So that was good there. So one of the ones that did come up is you mentioned public. There's some confusion on what the public role is. You know, what perms does it have? Why? How is public even around? How does it function?
So public in the SQL Server database, especially for your involuntary DBAs, is the equivalent of authenticated users. It exists. It's a catch-all group. If you have access to the database, you're automatically in the public role. You cannot be pulled out of it. It has a minimal set of permissions to basically query catalog views and that sort of thing that you need to query if you're a user in a database. But by rule, you should not grant any rights to it unless you're dealing with a special use case where you also enable the guest account, the guest user, which is a special use case that's completely outside of what we're talking about today. We can talk about that. I've actually written a couple of things about that, so some other folks, but public is just there. It's like authenticated users. It doesn't, you can't get rid of it. It's there to stay.
So should people, I mean, so It's required then for any account that comes into the system then, into that
Yeah,
database.
and
Yep.
if auditor asks you why is so-and-so a member of public role, because that's the only way SQL Server works.
Yep. Yeah. Um, so you had a couple examples here of where you created users without logins. What is the use case for that again? What's the best? What's the best use for that?
So there are cases when you want objects owned by something that shouldn't ever be usable. So let me pop back over to here, and I will minimize databases and go to two particular logins. This is at the server level, right? Notice you see AdventureWorks DB owner and Worldwide Imports DB owner. From a principle of least privilege perspective, the SA or the renamed SA account should never be the owner of a database. So like for instance, if I come here to AdventureWorks and I do a properties and I check who the owner is, notice it's listed as AdventureWorks DB owner. That is a standard login that has no specialized rights. And as a matter of fact, if you see the icon, it is disabled, right? At the server level, that's the best I can do with creating a login that shouldn't be usable to assign the databases to, right? Because I don't want a database owner to be, say, SA or something like that. That's just, there's too many rights there. It's not something that should be done. So if you need to have a similar case within the database where you have an object that for some reason you don't want owned by, say, DBO or something like that, you could create a user for that. The other reason, especially in development, is when you are trying to build a test case, a unit test, for instance, and you don't have the entire structure for logins and users, you can build particular users, build particular roles, add them to the role, and test their permissions to make sure that the permissions for the role are correct. That's the case that I see most often is in development to test role permissions. And to verify access or verify that access isn't there for that particular role.
Okay. Let's see. There's a couple that came in here now. I'm trying to read through it to make sure I understand it so I can read it. Okay. Does the ownership chaining work just for execute on the entire schema, or will it work if permissions on that store procedure only?
So the way ownership chaining works is if I have one object referring to another, and this could be a view referring to a table, and I'll give you a great case for that, right? Let's say the base table has a social security number, even if it's encrypted. For the most people, you don't even want them to know that the column is there. I might create a view that has every column but that sensitive social security number column here in the United States, right? Um, and if I want to make sure that they always use the view and not the table, then what I can do is I can grant select permissions against the view. And that means they only have the subset of columns that I let them have. If they were to try to execute against the table, they would fail. And so in that particular case, I do have to have permissions against that initiating object, right? In this case, the view. I do have to have permissions there. If it's set up right, I have no permissions against the back object because that just defeats the whole purpose of the ownership chain. So yeah, you have to have permissions on the object that's making the reference. You have to have the right permissions to use that object appropriately, right? So if it's a stored procedure, I have to have execute against that stored procedure. If it's say a view, then whatever TSQL command that I want to pass back through to the table itself, I have to have that particular permission on the view. So there are cases where we'll create views that people do insert, update, and delete against, for instance. And so you would have to have insert, update, delete against the view. But if you just wanted like reporting, you would only say have select access.
Cool.
Hopefully that answers it.
Yeah. If it's not follow up, if there's a follow up question, please type it in and we'll ask that. Here's one that I know is pretty popular. How dangerous is the NT Authority anonymous user if it's active?
It's equivalent of guest, right? So the thing about NT Authority anonymous user is if I don't have a security context for you, that's what you come in as. And likewise, if I have the case of you have guest turned on the database level, for instance, and I don't know who you are based on any of the other users that are defined in the database, that's who you come in as. And whatever access that has is what grants you access. Now, normally when we see an NT authority anonymous user, that means we have a problem with the number of hops. Say you have
Oh yeah.
a web browser talking to SSRS, and obviously the web browser is on the user's workstation, whether it's a desktop or a laptop. The SSRS box is on a web server somewhere, or is on a server itself. And if the SQL server that it's talking to is not on the same server as the SSRS server, and I don't have the authentication hop set up using what's called Kerberos delegation, I get in that multi-hop situation. And so when I go from SSRS to SQL Server, I don't come in as a known user because I drop back to something called NTLM, or without Kerberos delegation, I'm limited to the one hop, which is the browser to SSRS. And what that means is that I actually have a security configuration issue at the Active Directory / Kerberos level, right? Because I need to do something called a service principal name, which you can look up. You can, Kathy Kellenberger has done some great articles explaining how to set all this up with regards to Kerberos delegation and SSRS. That's the basic model for the multi-hop situation. So if you see NT Authority Anonymous login, it generally means that something's not set up right. That's the real danger, right? Is if you start granting access to it, you're basically granting access to something that's misconfigured. And obviously, because you've done that, someone else can take advantage of that and try to come in. And if they don't have credentials, like I'm using a Linux system that is not on, that doesn't have any way of authenticating, now I can come in the same way and execute the same permissions. So definitely you want to try to avoid that wherever you can and find where the security breakdown is in your configuration.
Okay. There's quite a few here coming in, so I'm gonna try and pick a few that are a little different, but not a whole new topic. Some of these
Okay.
are like whole new sessions. So, and I'll forward these off to you, so maybe we can shape a future session.
Yep,
Um,
that sounds good.
Here is okay. You mentioned about not using SA, but using you know, a user without a deactivated user. Why not use SA as owner of the database?
Well, there is
It's
something called
5,000 words
ownership.
or less.
Yeah, so there is something called cross database ownership chaining. And this is if SQL Server can map the owner up to a login and you have that turned on, whether you turn it on server wide or you turn it on for particular databases, you could have cases where someone has permissions within one database, and without you expecting it, they can go and hit objects in another database that they normally shouldn't have access to. And by the way, it is turned on particular system databases, master and tempdb, and it has to stay on. But that's the main reason, because you can have cases like that because it's the same owner. Notice that I made two different names for the different database sets, and that was on purpose to prevent against that cross database ownership chaining in case I mess up and turn that configuration setting on for some reason.
So I guess a follow-up question for that would be is, so if you have an environment with multiple databases on it, should each one have a different owner?
Generally speaking, yes. Now, in my particular case, if you looked very quickly, you saw I had AdventureWorks and I had AdventureWorks DW, both 2017, right? Those two databases, since they're a matched set, I've allowed to have the same owner. But generally speaking, yeah. Matter of fact, you can write your create databases if you automate to also go ahead and, if it has the proper permissions, to create the login, disable it, set the strong password, and so on and so forth, and make sure it has minimal permissions. And then just make the database that you create owned by that login, and you should be good to go.
Yeah, there is, and one last question here, and thank you for being patient, Brian, is do you recommend using the GUI to grant access or a direct script or something else?
If you are doing it one at a time, my recommendation is use what you're most comfortable with so that you have less of a chance to make a mistake. Where possible, you want to automate, and that means that you're using scripts, probably parameterized scripts that get executed and run, because obviously the more that you automate, the less chance of human error.
Yeah, yep. All right, with that, folks, I want to thank everyone for attending and give Brian a big thank you for giving us a good overview for security, SQL Server Security. We will have future sessions coming up the rest of this year on security. And so I welcome you all for that. And we'll see you all April 22nd for the next session. Thank you very much. Be safe now.